Hi everyone, I'm Themi Zamani. I am from Greece, from GRNet. I'm a senior project manager there, and I'm head of the implementation unit of European Infrastructures and Project Directorate. I started working with persistent identifiers more than 10 years ago. When did EPIC start? Long enough. In EUDAT, I am the service owner of the B2Handle service, and today we're going all together. We will try to present what a persistent identifier is, how you can use it, which are the different types of persistent identifiers, and what is the organizational structure of this whole ecosystem. So the agenda, we have two sessions. We have, now we're going to have before the coffee the first session. And the first session has the persistent identifiers. What is a persistent identifiers? What is a persistent identifier? How they work? The structural organization of persistent identifiers, the ecosystem and the layers of sustainability. And finally, we're going to have a demo and let's say a part of a hands-on where we are all together going to create some basic persistent identifiers via our service, the EUDAT B2Handle service, and the different ways it supports. Via the PyHandle library, and of course via API calls that we can directly use so that you can easily create and manage your persistent identifiers. So I'm going to start with the small introduction of the persistent identifiers, and then my colleagues will follow with the structure, the layers of sustainability in the PID ecosystem and the hands-on session. And they're going to. Do you want to introduce first of all yourself? Now?
We can do it later.
Okay, you want to do it later, no problem. So, I will start my presentation with something different. I will not start with what a persistent identifier is. I will start with the user requests. These are real examples, requests that we had via email or mainly via email and via the help desk system we have in EUDAT. And they're real user requests that want to learn and use persistent identifier in their system. So some of them are good day support. I'm interested in using PID in the repository of data that we have in the organization. What do you have to do to sign me up to your system? Hi, B2Handle support. Please provide me with an account. I would like to use to obtain PIDs for an application we are creating. And the last one is I'm writing to you to get some technical support for a project we have. The task at hand is to issue data project persistent unique identifiers using your service. These are a few emails we had, and if you have a look at them, you can understand that what we see from these emails are the user requirements, how they understand what a persistent identifier is, and what they expect from our service, the EUDAT service, the B2Handle service. Some other user requirements we have put in this slide. These are again user requests, but for something different. They want, if you see from the emails, we can have a look at them. They want specific types of persistent identifier. They want, for example, in a session I was participating, I heard about persistent identifiers for organization, and I would like to ask you if you can help me provide PIDs for more organization. Another email was asking at persistent identifier for material samples, or the last one was asking for persistent identifier for historical data. So you can see that we have users that understand by the use what a persistent identifier is. They want persistent, we have different users that they want a persistent identifier for different domains and for different data, as you saw in the first slide. All of them have a common goal. their common goal is to optimize the utility of their data. And how they want to do it, they have some common data principle in mind. What is happening the last few years is that they all want to make their data fair. Have you heard of fair? Okay, so the last few years there is the fair data principles that they were elaborated in order to optimize the reusability of research data. According to these principles, you have to make your data fair, which means findable, accessible, interoperable, and reusable. When we mean findable, it is easy to find by both humans and computer systems. Accessible means that they should be stored for long-term, accessed and or downloaded with well-defined licenses and access. Interoperable means that they should be ready to be combined with other datasets by human as well as computer systems. And reusable means that they should be ready to be used for future research and to be processed further using computational methods. That's the idea that, and the explanation of the four different words: the findable, accessible, interoperable, and reusable. The idea here also is that this data should follow these rules not only for humans but as well as computer systems, because now we need the data to be readable by computer systems and accessible. In this slide, I put it for you when you get the slides what findable, accessible, interoperable, and reusable mean, and what they should follow what you should do to follow these data. And let's see what is going on now in your field, in the research field. The data generation is getting all day by day easier and cheaper. And at the same time, there is a shift from data generation to data processing and analysis. It's actually a new way to do your science. As a result, the amount of data output is increasing, and we have to find a way to stimulate reuse and to enable reproducibility. That's why the persistent identifiers are increasingly important, and they are applied in science and in various sectors and domains in science. And the sectors cover the science, industry, governments, different sectors that we're all working on. And the data management experts are becoming extremely dependent on these persistent identifiers, and the availability and the functioning of these persistent identifiers. So, what is a persistent identifier? Do you all know what a persistent identifier is? Have you used the persistent identifier? No one? Okay, this is a type of persistent identifier, right? You don't have a persistent identifier for yourself, an ORCID? Sorry? Do you have an ORCID? So you all have your first persistent identifier. That's a persistent identifier. So an identifier is a unique identification code, a code that we use and is applied to something so that you can always refer to this something easily. It is an identifier that is effectively, permanently assigned to an object. We're trying to use these words because this is the difference and the added value that a persistent identifier has. You can use persistent identifier in the different stages of the research, like analysis, enrichment, registration, preservation, and of course in different types of data, like raw data, publication, suitable publication. So you can use it everywhere in order to support your work. It points to a resource. So your ORCID, let's say, that points to information about yourself, your publication, your education, everything that has to do with yourself. A DOI can be part of, can point to a date, an object. So it's something, it points to a resource. It is globally unique, And the structure of this persistent identifier is defined by a prefix, which here in our example is the 21.123, and a suffix, which is a string that you on yourself can choose how to apply. The prefix is the administrative domain and comes from an issuing instance. We can match the word of this issuing instance, like when you want to buy a domain name for your site. It's like you can compare this with the prefix. And the suffix is something unique in the realm of the prefix. So you create as many strings as you want under your prefix, and the combination creates the uniqueness of the persistent identifier. Once the persistent identifier is created, by the time it is created, it is globally addressed. This is by design. The persistent identifier can be used via an actionable URL. So instead of just having a prefix and a suffix, you can use a URL where you can be redirected to the resource and the object that the persistent identifier refers to. The main question we usually have when they see that, I have a persistent identifier that can be a URL, and it is an actionable URL. Why don't we use URLs instead of this actionable persistent identifier you are referring to? The answer to this is that the URL is something different. It specifies the location on a server where you can find your resource. It is strictly a network location for the digital resources. But what happens? Imagine yourself that you put a resource in a web server in your organization. Let's say that in GRNet, I put a resource under the domain name grnet.gr with the name my first resource. Sometimes in some organizations, due to internal decisions, the domain name may change. So instead of finding the resource in the grnet.gr domain, you have to imagine that you have to change the domain name to find the resource. So the domain name changed, you cannot find the resource. Another thing is that the resources may be relocated. Let's say that in GRNet we decided to use another software to host our website and our repository and our resources. So the location of the resource changed. And instead of finding my first resource under the domain name GRNet, they decided to move all the resources under a folder named old resources. So again, you will not find the resource you are searching for. And based on all these problems, the URL is not the correct solution because in the longer term, after a few years, the URL does not work and you will not find the resource you want to find. So actually, this is why persistent identifier help us, because a persistent identifier is a long-lasting reference to a digital object. It could be a single file, a set of files, whatever you want to refer to, and it's not a URL. The persistent identifier is something different from a URL, as we already said earlier. What it does, it points to a resource with no actual data of the resource. He doesn't know what the resource is, he just knows always the location of the resource. You are sure that by using the persistent identifier, you will always find the resource without knowing the exact location. By the time, though, you decide to use persistent identifier, you are an owner of a persistent identifier, and you are responsible to update the persistent identifier. So, if the location of the resource that points to the persistent identifier changes, you have to update your persistent identifier. You have to use the services that help you update the persistent identifier, and always keep the persistent identifier up to date. That's the success of the difference of the persistent identifier and the URL. Once you create the URL and it changes, you cannot find again the resource. But if you use persistent identifier, the persistent identifier will stay the same over time, pointing to the latest location of the resource. That is the persistency that the persistent identifiers have, and they are there by design. Even if the real location of the data of the resource changes, the persistent identifier will always point to this one. That's the redirection layer that the persistent identifier have, and they solve the problems of knowing the location. The user has a string which is resolved to be a URL, and he doesn't have to know the URL. With the string, he always knows where the position, where the resource he's looking is. So, what we do in EUDAT? In EUDAT, we have a number of services that are a part of the different stages of the research in the data management, the data discovery, the data access and sharing, the data management and preservation. And we use in our B2 services, I don't know if you have seen some of them yesterday or we use persistent identifiers so that the researchers can easily access the resources via persistent identifiers. So now that we finished with what a persistent identifier is, Tibor will present you the PID ecosystem and the layers of sustainability.
So just a short sound check. Can you hear me? Yeah, good morning. My name is Tibor. I'm from Göttingen, Germany. Göttingen is more or less in the middle of Germany. And we both work at the local data and computing center in Göttingen, which is one of the major partners in several consortiums regarding data management and regarding persistent identifiers. After Tammy's introduction, we know that persistent identifiers is a kind of a solution for the problem of sustainable referencing and sustainable identification of digital objects. And persistent identifiers introduce a kind of a redirection layer. So the user has a PID string on the left, and this is somehow magically resolved to a URL, and this URL points to the digital object. Now I will shift my focus on the box in the middle, because this is the most important part of the whole process, and this describes how to do this resolution, how to do this maintenance of PIDs on the right way. Just to give you an example, around the COVID times, there were lots of data sets. They have been published. They got PIDs, persistent identifiers, and the persistent identifiers were published and shared with other researchers. So the resolution of these persistent identifiers is important, because you don't want that someone can just hijack itself and redirect you to wrong data sets, which describe probably other scientific bases than you were mentioning in your original data sets. So the importance about the organizational sustainability and the technologies behind the persistent identifier ecosystem is important. First, I will briefly talk about the operational sustainability and organizational sustainability. So what does it mean? This describes how decisions are made in the respective PID infrastructures, what are the business models behind the persistent identifier infrastructures, how much you need to pay, do you need to pay to assign a PID to resources, or how transparent the governance is, who makes decisions in these infrastructures. Can you somehow ask new features? Can you somehow influence what kind of standards they are using? And similar questions. So let's start with the organizational structures and with the organizational part. Why it is important? It is important because technologies alone are not sustainable. Even if you found the best software or best tools ever for maintaining persistent identifiers, resolving persistent identifiers, that will not work on its own. Technologies are constantly changing. Interfaces of services are constantly changing, and sometimes even the requirements around the technologies and around the services are changing. Another aspect is that lots of work is carried out in projects. Probably you know scientific and research projects. Every project has an end. So if you try to deal with persistent identifiers in a project context, what happens when the project ends? Will the services run after the project ends? So project structures are very interesting because you can do a lot of new stuff in project context, but the context and everything is in the project context is very limited. And other aspects then, when it comes to how to run services, IT service management is important. But a PID ecosystem and everything around the PID ecosystem is a bit more than just IT service management. I won't go into the details here and now. My point is that the PID service and the whole PID ecosystem can only be operated sustainably if the organizational structures which are backing these systems are sustainable. So how could such an organizational structure look like? On the next slide, on the next slide I have an example how we do it in Göttingen. Because the campus in Göttingen is quite big. There is a huge university, a large university. There are quite some Max Planck institutes. These are research institutes. There are institutes of the German Aerospace Center located in Göttingen, and there are other research institutes. They are all based in Göttingen. So for the campus Göttingen, it was always important to participate in such sustainable organizational structures around the PIDs. Therefore, in the PID area, Göttingen became involved in the Persistent Identifier Consortium in EPIC, which deals with handle-based PIDs, but Göttingen is also participating in DataCite, where DOIs are assigned, participating in Crossref, where also DOIs, other type of DOIs are assigned, and also member of DONA, which somehow governs the whole handle-based PID world. I will very, very briefly show some slides of these organizational structures, just to put them somehow in the context. Yeah, the first example is EPIC. Without going into the details, I'm just mentioning 3 main points here. EPIC is a consortium, the Persistent Identifier Consortium for e-research, which provides PID services for researchers, research institutions, who cannot run or do not run PID services on their own. All of the founders of the consortium are well-established data and computing centers, so they are big players, and they have a long experience in the operation of stable and highly available services. Many of these data and computing centers have been existing since more than 50 years, which is quite a long time in the area of data management. They are all involved in various e-science projects. What does it mean? They are not coming from the sector of publishers, having a commercial business model, but they try to support somehow the research and the research sector, and their goals are definitely quite different from the publishers and from the commercial sectors. The next example is the DOI. The DOI word, some of you have mentioned that has already seen a DOI. Yeah, just to say some words about it. So there are different organizations around DOIs. One of them is DataCite. DataCite had the original focus on the assignment of DOIs, on the assignment of persistent identifiers for published data sets. And it has registry offices distributed worldwide. I think I mentioned an example on the slide how it's done in Germany. In Germany, there is a consortium, or there was a consortium created for DataCite members, and the consortium members are responsible for dedicated scientific disciplines. The discipline of humanities and arts are somehow served from Göttingen. The university library is responsible for assigning DataCite DOIs for any kind of humanities, digital humanities projects and institutions. And yeah, if someone needs a DataCite DOI in Germany, it goes to Göttingen and gets its DataCite DOIs. Another example is Crossref. Crossref is coming from the publisher sector. It was founded around when the first electronic journals have been created, and scientific articles in these journals have to be identified somehow by PIDs. Founders were Elsevier, Nature, Springer, and some others. If you have ever heard about Elsevier, Nature, Springer, you know that their business model is quite different from the way how you ask services from your local data centers. It is said that that quite some publishers go to Crossref. It is also in Göttingen like this. Some of the electronic journals are hosted by the University Library and State Library in Göttingen, and this is responsible for assigning Crossref DOIs to these journals and to these journal articles. The next example I have is DONA. This is the Digital Object Naming Authority. Some of you might have heard about the history of Handle-based PIDs, the Handle system and the governance of the Handle system. So the Handle system was created in the US, in the United States, and at the beginning it was also governed in the United States. Of course, this was not acceptable for some of the global players, basically for those who are coming from the eastern part of the world, because they do not want to trust in any US organization just to govern and assign their PIDs. So that's why it was quite important to set up an independent and jointly governed international entity, a kind of a consortium. And this is the DONA Foundation. It's based in Geneva, and it's a Swiss foundation. And because of the importance of this consortium and the importance of the influence of this consortium in the Handle world, we in Göttingen found that it's important to support this initiative. So the Data and Computing Center, where the both of us are from, is member of this consortium and pays the annual membership fee on behalf of the PID consortium. Okay, so much for the... Yeah, they are also using handles. So much for the organizational structures for the moment. There are many other organizational structures exist in the PID ecosystem, but there are also many technologies exist. So I'm now coming to the point of the technical sustainability and technical reusability in the area of persistent identifiers. Just to make it clear, at the very beginning, there are lots of PID technologies. So there is no one technology which rules all. There are many PID technologies. The organizations I mentioned before, and also many not mentioned ones, do not build a new technology for the PID services, but instead they use existing ones, which are proven technologies that have been with us for decades. I will now briefly show some examples. I won't go into details. I added all these slides to the presentation one by one, so if you are really interested in the technological details, you can check the slides on your own after our session. I'm just mentioning that the handle technology is one of the major technologies in the PID world. It is really utilized worldwide. The development of the handle system is financed by fees for registration of namespaces, so-called namespaces, and the basic technology of the handle system has existed for about 20, 25, probably 30 years. The DOIs, which you have heard about, the technical basis of DOIs is the handle system. So the DOIs are kind of a branding of the handle-based PIDs, and the whole DOI infrastructure, PID ecosystem, is managed by the International DOI Foundation. This is also a consortium, have both commercial and non-commercial partners, and currently they have 12 agencies around the world which are able to register somehow DOIs. There is also an ISO standard for the DOI system, and the metadata, in general, the metadata in DOIs are very well standardized. This has advantages and this has disadvantages. So if you need freedom, you need to live somehow with this well standardized PID schema. URN is probably the next, is also a standard for identifying resources. Nowadays there are more than 100 so-called schemes or sub-schemes exist and namespaces exist. These schemes and these subsystems can be integrated into the URN namespace as independent namespaces. So basically, ESBN numbers, you probably know every book has an ESBN number, a book identifier number printed on the back, on the cover page or on the back of the books, or in the libraries, the resources get an NBN number, National Bibliography number. These just can plug into the URN word, and existing numbering system can be used in the URN-based PIDs without bigger issues. That's why URN is very common in libraries who deal with these existing systems. ARC is also a technology, the last one I want to mention here. This is somehow special in a way that it can be used on 3 different methods. An ARC PID can link to an object, a digital object, can link to the metadata of the object, or it can be linked to the provider or institution of the objects. Some other technologies are also out there. What I would like to highlight here, that the concepts in these technologies are always very similar. So there is a unique ID, the persistent identifier string. There is a resolver which knows how to redirect to the location of the digital object. We will skip the detailed slides. You can check this after the presentation if you are interested. And now let's check how this applies to EUDAT. So this, please skip this, and yeah. Here we are. So how to position EUDAT in the organizational structures I was mentioning, and what to say about the organizational structures and the technology used in EUDAT. On the left, you see that EUDAT provides a handle-based, so that the handle-based service, and all of the EUDAT B2Handle providers are part of one of the mentioned organizations, in this case the Persistent Identifier Consortium for e-Research, and EUDAT services, EUDAT B2Handle services are operated according to the policy of the PID consortium. EUDAT has also a data site consortium, which enables us to use DOIs in the B2 services provided by EUDAT. When it comes to the technology, then the handle-based technology is used, and the DOI-based technologies are also offered. On this basis, EUDAT has built up added value services and other services which can assign PIDs, for example, to instruments, scientific instruments. This is just, next slide please. This is just to show that we have a service called B2Inst, which is a service to reference, describe and register scientific instruments. This showing the landing page, how an instrument is registered in the system, and how the landing page looks like. We will have this service later on. With that, we are coming to our demo session. The idea now is, can you open please the hands-on part? We probably need to switch.
I think, yes, you have to take it now.
We need to switch computers because we have prepared everything here. Why this is happening? The idea now is that we will show you how a persistent identifier, how a handle-based persistent identifier can be created. First we show how a persistent identifier looks like, what is it, and we will show 3 different ways how to create more or less the same PID. Slideshow. Yeah.
Is it possible to share the link to the slides?
Yes, we have the slides now. If you want.
Yeah, I mean, if you are not, because they are not in the chat. So
yes, we will send.
Yeah, the slides will be shared.
And the hands-on we can share it from now because we have. Huh?
Yeah. So what we are doing now is we create the same PID on 3 different ways. If you jump one slide back. So what is a PID record? How a PID record looks like? Basically, a PID record is very simple. There are just keys and values. And one of the keys might be the URL, so where to point this PID. There might be additional metadata. There might be some additional metadata in the PID record. In our example, we will register a PID for the web page of the summer school. So the idea behind it, if you make any changes in the summer school URL and you publish the PID to the summer school and everybody has the PID, then you can update from time to time to a new URL, and with the PID will be resolved to the correct URL. We put some extra metadata just to describe what is it. We put a title and description in this PID record, and if you jump.
We have to say here that we're referring to B2Handle.
Yeah, we will use the B2Handle service for these examples. And you see 3 different ways. how to create persistent identifiers in the B2 handle service. On the top, this is a web browser-based web application. So I will just open a browser, go to the service, log in with the credentials directly in the service, and create a PID record. The second way, more or less in the middle, we will use some Python code and use the PyHandle library, which is a kind of an abstraction layer to the B2 handle service. And from the Python-based code, we are creating PID records in the B2 handle system via the REST API using the PyHandle library. And the third, and probably the most complicated way, is using the REST API directly when you use post and put and get requests to create, maintain, and
Yes,
read the PID.
Via the Postman tool, you are not going to write
Yeah.
it on your own. You are going to use a tool to do it.
Okay, then we need to go to the URL. I think which one is this is used now. So I would need a browser.
They're going to use this URL. It's working.
Mm-hmm.
Ah, you do it.
Yeah, partly.
Because they are typing the URL.
This is the URL of the service. We will share the URL later.
No, in the chat. URL in the chat.
Yeah, you have a URL.
This one.
In the channel. In which channel? Sorry? In the Downsquare, I think. Okay, Downsquare.
Yeah. Probably
You cannot see it from your URL.
Yeah, I have the issue that I need to use this keyboard, but I need to look there. So I try to manage somehow. Yeah, so this is a small web application provided as part of the handle system. Usually we do not advise people to use this web application because it has its limitations, and most of the customers using the B2 handle service try to include the maintenance and minting of PIDs into their scientific workflows, which means they programmatically work on data sets and they programmatically would like to assign PIDs. But this is an easy way to present how to deal with the system. So usually making changes in PIDs requires authentication. The handle system uses a very interesting way of naming users. Everything is a handle in the PID word, and I hope that I type what I want to say.
I can help copy paste.
Yeah, can you copy paste because the password is
He would
a
need
bit more.
5 minutes to go to
Yeah,
write.
it's a long one. So what basically I do here, I put my username and password on a specific way, how the handle system requires to have this, and after that I'm logged into the system. Here is the password coming.
Ta-dan, ta-dan.
Authenticate, yeah.
Yeah.
And now I'm successfully logged in. What I'm doing now, I'm trying to click together a PID record I showed, similar to what I showed on the slide. So I will add several values to this record. There is one, this is somehow needed as a kind of a technical metadata just to know who is the owner of this record, but adding new values, I was saying that I want to have a description.
You're writing up.
And we said that this is somehow something like summer school page or whatever.
The index? You will usually in the index 1 will put the URL.
And then I want to have, what was it, a kind of a title,
Summer
which
School
also says
2020.
Summer School. Or something like this. Ah, sorry. How time flies. And we wanted to add a URL. This is, I have no idea. Something, Summer School. Probably it's not the right one, but you got the idea, right?
Yep.
So this is how my PID record looks like now. If I click on save, then it should be saved on the PID server. So this is the easiest way to create PIDs by humans, but this is probably not the best way for machines. Now we will present other ways. If you go back, this is the presentation. So next slide, please. Yeah, now this was the upper part of the figure. Now we are going to use the middle way, using Python code to create, update, read, and probably delete PIDs. I hand over the mic to Kajaani.
Okay, it seems. I hope you all can hear me. Okay, so I am Gökçenin Çakır. I am going to present you this middle part with the Jupyter notebook and PyHandle library. We are going to explore PyHandle library in the Jupyter notebook and how we can use the handle system's REST API. So, what is PyHandle? PyHandle is a Python library which acts as a client and it interacts with the handle system. It provides us with the functionality to create, read, update, and delete capabilities for the handles, or in other words, handle PIDs. This library is open source and it is available on GitHub. If you are interested, you can check that repository to get more in-depth knowledge about it. So what is REST API? If you are not so familiar with those terms, REST API is a way for the software applications to exchange data, communicate with each other over the internet. It acts as a similar, its functionality is similar to a waiter in a restaurant. So in this case, the clients would be other applications or systems, etc. And the REST API provides information or performs the requested actions that are requested by you. These requests are standardized instructions like get, post, put, and delete, which helps you in the case of PyHandle create PID, retrieve the value of the handle, and modify as well as delete the handle. PyHandle also offers an interaction capability with the handle server's SQL backend, but this is not our focus for now. But it could be interesting if you want to go one step further. And lastly, it offers a bulk upload functionality using the generic batch command utility of the handle system. It allows you to create a batch file, and that contains different operations that can be performed on the handle system. So a small example here, a Jupyter notebook. So what is a Jupyter notebook? After the slides. Jupyter notebook. What is a Jupyter notebook? Jupyter notebook is an interactive environment. It allows you to execute small pieces of code in small sections, or you can re-execute your code if you made some modifications, corrections, or whatever. It provides us with an organized and structured way to explore our code's data, and in this case, the REST API responses. It helps us collaborate with the other people, other developers, other colleagues, in a very similar manner to Google Docs or Microsoft Docs. So in the slides in that slide you see at the very top it says 81. There is a import statement. They are going to be used to nicely display the nested JSON objects or Python dictionaries. We first initialize we first import the PyHandle libraries REST handle clients, and then we define our print nicely function so that we can nicely display our deeply nested Python dictionaries or JSON object. We use our username as a prefix so that the PIDs that we created can be distinguished, and so on. And these credentials are important. This is the first important step for the interaction with the with the handle clients. Hit the REST API of the handle client. We use handle server URL. This is our handle server. We need a username and password, and also our prefix. We can add as many suffixes after the prefix as we like. So we first create our metadata. In this case, it is EUDAT Summer School, and its description, EUDAT Summer School's description link. This is going to be our metadata. We initialize the REST client with the REST client classes initializer. And then we call generate and register handle function with the prefix that we defined previously. Here 21.t15999, and we define a location. In this case, it's a URL. It is wrong for the demonstration purposes. We are going to change it later. It ends with 22, but we are going to change it 23 later. Checksum is an optional argument. Yeah, we don't need to supply it. It is known by default, and our metadata that we have defined previously. And after executing this function, we are going to receive the the PID that we have created, it is generated randomly, and we can print it after assigning the return value of that function. So, and with the retrieve handle record, we can get more information about the handle record, including the URL, title, description, and hsadmin that we all use in the previous steps. And now we are going to modify that URL. We define a new URL. We call modify handled value function, and we use the PID as a parameter or argument that we have fetched previously, and we also pass our new URL as a parameter. And after executing this function, we are going to see that our PID is not changed, and then we get the most current value of our handle, and when we print it, we see that at the end you can see 23, which means it is successfully updated. And also when we call the retrieve handle record function to get more information about the handle, we can see other key value pairs as well. And lastly, we can delete a handle if we don't need it. If we want, we simply call the delete handle function and pass the handle PID as a parameter. And when we print the response, it will supply us with the PID of the deleted handle. And when we try to print and when we try to fetch that handle with the PID that we created previously, it is not going to find it because it is deleted. So I am going to execute this step by step. It is the same code, but it is a live Jupyter handle, a Jupyter notebook. You can start with you should start with the imports, and this is the function that we are going to need. Here you can yeah. Here you can type in your.
It's in a public Git repository.
Yes.
We will share the link.
We are going to share it with you sometime after. Here you can type in your username as a suffix. You should define credentials. It can be also a public and private key pair, but in this case we are going to use password authentication, and we can see whether we have successfully defined the credentials. And we initialize the REST client. Then we define our metadata. You can define as many key value pairs as you can, but the problem, it is going to be a problem if you have deeply nested Python dictionary. So it should be a simple key value pair. Then I am creating a handle, a randomly generating handle PID. And I am calling generate a register handle function, So it has executed and assigned the return value to this variable, and then we can see the handle PID that we have created. If I copy this and go to the handle system and resolve this PID, I am going to go to the URL I defined previously.
If you go back again, please.
Yeah.
And you go back.
Yes.
And don't redirect to URL so that they can see the
Mhm.
record.
Yes, that's also another option if you want to get more information.
So
About
we created the handle with the values that he described. You can see the record, the PID record in the handle system that we have. And if we use the proxy without selecting dot redirect, it will just redirect to the URL of that is defined here. That's the idea of the persistent identifiers. And now you are going to update.
Yes, I am going to retrieve the handle value that I created, and it is the same thing that you see here, but as a Python dictionary. And I want to update that value with the correct URL. So I define new URL, and I call the modify handle value. And as you see, the PID has not changed, as I said previously, but the value has changed. So it is the same thing that you see previously.
You refresh, just refresh.
Continue.
So we have the by handle library. He updated the URL. Instead of using 22, he updated to 23. And you can see that it is automatically updated in the handle system. And again, you will be redirected if he goes back. Oops. Remove the DOM. And now you will see the page with our EUDAT Summer School.
It is now the correct link. Yes, I can also get do the same thing and get the correct value again via the get value from handle function. And now I am getting the other key value pairs such as title and description, and they are not modified. We only modified the URL. You can also modify the other key value pairs. And lastly, I am going to delete that handle. Again, as you see, the PID value is not changed. It is the same PID value that you see here previously, but it is deleted. It no longer exists. So if I go back, don't redirect, and resolve it, it is deleted. No, it is.
Not yet.
Yeah, it is deleted,
Okay.
but it's either in cache or something.
Yeah. Okay.
So
How much time do you have?
I'm done.
15 minutes left.
15. Okay. We are going to do the same actions by using an API. Have you ever used the Postman? Do you have Postman in your laptops? Yes. Perfect. How many of you do you have Postman? Okay, I will put the URL to download the Postman. I think I speak loud enough.
For the recording.
You want the display? Yeah.
I want the display. I will put mine because I have already adjusted. You can also create an account on the web application of Postman and not download the Postman. If you go to Postman online account, it's okay, it's the Postman. I'm trying to find the Mattermost to send them. If you don't want to download the Postman, you can create online an account. And I will also send you the two files. When you are using Postman, you need the environments, which has the username and the password, so that you don't use all the time the username and the password and you're using it as variables, and the actions and the data that you want to post. The Postman, what it's doing is sending API requests to the server, not via your command line, but by using Postman. That's what we're going to do. We're going to use API calls via Postman. It's, if you have used an API, it will be easy. So, I've sent you the two files. The first one is the API calls and the second one is the variables. Sorry. So if you
Can you make it a bit bigger?
I'm trying. It's okay. The fonts, you mean?
Yeah.
Can you see now? Okay. Did anyone try to download, use Postman, and upload the files? Okay. Does anyone need help to do for this?
Probably you can show first. You can show first.
Okay. So until you manage to download and use the files, I will demonstrate this type of the library from the API calls from here. So. We're going to do the same things that you saw in the Jupyter notebook with the API calls. So the first step was to create a handle. Where is the body? Here. Okay. Is to create a handle with a URL somewhere, with a title that says EUDAT Summer School and a description that says EUDAT Summer School description. Okay. So I will create a handle with the summer school. I will put my name here so that we distinguish. We all use the same user account. So in order to distinguish the persistent identifier, I will put in the end of the persistent identifier my name. So I will create via the Postman. And when you try to create, please use your name so that you can easily find your persistent identifier. And I will start creating, I will create my handle. Okay. view a handle. Now that I have created, I will try to view the details of this persistent identifier. What's going on?
Unauthorized.
Yes, because I haven't uploaded the environment, that's why. I will go to environments.
So what happened now is Temis has just demonstrated
Without user.
that the PID server, the B2 handle server, checks the username and password because she was not providing the right username and password. That's why she was not able to create the handle.
Okay, so I will import my environment here. And now we'll go back again. I will use from here the correct environment, the B2 handle environment, although I have a mistake in there. And I will try again to create my persistent identifier. Yeah. So we see that we have a persistent identifier and we have created the handle with the name Summer School Themis. And then I will go to view the handle, the details of the handle. You see that here we're going to get a persistent identifier with the URL that I told you, the wrong one, with the title EUDAT Summer School and the data EUDAT Summer School description. Now I found out that the URL was wrong, and I will go here again and update. And I want to update the URL and put the correct URL from the EUDAT Summer School 2023. In order to update, I will use the put request by selecting the index of the type that I want to update. If you see here, when I created this persistent identifier, it had index 1 is the URL, index 2 is the title. It's a way to distinguish the different types that you are using in your persistent identifier. So I want to update the index 1, which is the type of the URL, and I want to put the correct URL, which points to EU.EU Summer School, EUDAT Summer School 2023. I will send the request. And now this handle has been updated. If I go and view the handle now, you will see that the URL points now to the correct, to the Summer School page and not to the first page of EUDAT. There is also an action that you can update all the values of, all the indexes of the persistent identifier at once, the URL, the title and description, and what I put in the index, it's various. So I want to update all these different types of persistent identifier. So I put a non-existing URL, a type, a title, some metadata, and descriptions, other metadata. If I send, it's the wrong, sorry. If I send it and view the handle again, you will see that I got the latest values, some metadata value, other metadata value, and things like that. So this is the way to create, update, and update a value or an index, a type, one type of the persistent identifier, or all the types of the persistent identifier at once.